Hello and welcome to another video. In this one we're going to talk about how I'm accidentally maintaining a new package. An alternative title for this is how I discovered the problem with upgrading to Python 3.12 at Sentry and ultimately saved our rollout. Now, I know this sounds similar, and maybe you watched my other video about upgrading to 3.11. This one is actually going to go down a completely different path. But I will touch on that in a bit. Hi, me from the future. One slight correction. I didn't actually end up finding the problem with this video, but I think it's interesting watching the process that I did nonetheless. There will be a follow-up video where I go over finding the actual root cause and actually fixing it. It's a very deep rabbit hole. Anyway, back to the original video. Anyway, for a little bit of background, I need to explain what is uWSGI, what is pyuwsgi, and why does all of this matter? Now, uWSGI is a very popular application server for running Python web apps. I think specifically non-async web apps, although I could be wrong. And technically, uWSGI can run other languages as well. I've seen it used in Ruby, although I don't know why you would use it. And in theory, it can run other stuff as well. I think Perl, there's plugins for that as well. But it's most popular in Python, and it's, it gets used in Python a lot. The one problem with uWSGI, or at least with the way that it's distributed, is it is very difficult to make a pre-built binary for it, a wheel for it. And so all of the distributions on PyPI are source distributions. This is partially because uWSGI has a ton of different ways that you can compile it and configure it, and it can't possibly handle all of those in the wheel that it provides, or that it theoretically could provide. Additionally, uWSGI supplies just a single binary, and so it doesn't fit the normal kind of compiled module thing that a wheel would have. And so it doesn't really fit well with the PyPA tooling, and it's clunky to compile, and basically it's just not been approached by the uWSGI project itself. So along comes pyuwsgi. The idea behind pyuwsgi is to change the building of uWSGI and compile a very specific configuration that installs a subset of the third-party dependencies, avoids SSL because often vendoring OpenSSL is just a nightmare for security, and then is able to provide wheels for common platforms and Python versions. Here is just some of the versions for the latest released pyuwsgi version of 2.0.23.post0. You can see it's compiled for Linux, for macOS, different C library flavor of Linux, not macOS ARM, but we'll get to that at some point, and a bunch of different Python versions, so 3.8 or 3.7 to 3.12. And that project is managed separately here by a separate entity that's completely separate from the uWSGI maintainers, company called Lincoln Loop. Great. Okay, so all of that background, I want to switch gears for a bit and talk about how I got into this and why I'm even talking about uWSGI at all. And in order to do that, we need to forget everything we've said and start talking about my goal, one of my goals at Sentry recently, which is to upgrade our main repository, which is currently running Python 3.11 in production, to Python 3.12. And similar to my previous upgrade, I've carefully separated out all of the changes that need to happen before I can bump the version, and then made the version bump just another feature patch that can go to production. And when we rolled this out, we have many different environments. So we have a pre-production environment that we call Sentry for Sentry, where we actually run a special version of Sentry that also ingests Sentry logs from our production instance. And before we go to full production, we also go to a canary environment where we run the new version of code on a very small subsample of requests, and we check it for new errors and regressions. And if there are errors in Sentry, we use our own product and roll back a bad deployment. But anyway, with that background, I had upgraded 3.12. I had gotten all of the tests passing in Sentry as well as in our private repo that wraps Sentry called GitSentry, and I went to roll it out to production. And in our pre-production environment, everything worked fine, or at least seemed fine from our our logs, and we went to full production, and or we went to Canary. Everything seemed fine there. There were no new errors, except for a few where like an exception message had changed between Python versions. But that's always going to happen. Ideally, Sentry would do better about grouping them, but issue grouping is a hard problem. But everything looked great. We then went to full production, and things still mostly looked good. Although there was a bunch of reports of people receiving error responses from Sentry. And weirdly enough, Sentry showed that everything was great, except for these error responses. We also noticed that our internal RPC endpoints were often retrying more often than they usually would, and erroring out more often than they usually would, kind of corroborating this external errors problem. And so we rolled back. The biggest major change that had happened recently was upgrading to 3.12. So I was immediately the suspect, as it goes. It's kind of fair. And after rolling back and after scaling up, because a bunch of things happened at once, the errors went away. So presumably it was the Python 3.12 upgrade. After, once it's in a good state, I started looking into this, and I started finding some really interesting things in our logs. Oops, paste this. This is one of the log lines that during that incident period was quite elevated. Put a little line break here so you can see the whole thing. This is an output from uWSGI, and one of the ways that uWSGI works is it pulls a bunch of requests and has a queue internally. This queue is pretty small, so it can keep a bunch of requests open, and then in theory, workers can pull them off and handle them as they're available. And so the queue is usually about 100. It also has to deal with operating system level socket limits, but that's a whole different problem. And there was a background of these particular log lines before rolling out Python 3.12. And if you've ever run uWSGI in production, you've probably seen this and you probably know a little bit what's happening. This is a very bad thing to see. This means that uWSGI can no longer accept requests and is now dropping them on the floor. And your workers aren't processing requests fast enough. This is usually happens in a state where your app is overloaded, or you have application code that's either deadlocking or really slow, or you just don't have enough machines to handle code. This is a very bad log line to see. And despite it happening in the background, which is another problem that I need to follow up on, it was spewing lots and lots and lots during the 3.12 rollout. And so my initial thought to this, and similar to my 3.11 rollout, my initial thought was, oh, okay, something in Python 3.12 is a lot slower than in Python 3.11. And so workers are backing up because they can't do the work fast enough. That was my first hypothesis. It was dead wrong, but it was my first hypothesis. And so I went through a whole bunch of work to profile the difference between 3.11 and 3.12. I used a similar approach to what I used in the 3.11 video. I'll try and remember to link that in the description. But in 3.11, I used a tool called pyspy to profile 3.10 versus 3.11. It's a sampling profiler, has low overhead, and allows you to generate flame graphs. Unfortunately, pyspy doesn't yet support 3.12. 6 months ago, so it hasn't changed since the last week when I looked this up. pyspy doesn't support Python 3.12, so I've been using this other package, Austin dist. This other package called Austin. Austin is a different sampling profiler, and I actually really like this program. I found it during this investigation, and admittedly it didn't actually help me solve my problem, but it seems a lot nicer than pyspy, at least in its interface and how you run it and the outputs, and it's a great sampling profiler, so you should check it out. Anyway, off topic because this didn't actually solve my problem, but it did give me some insight into how things are running in production. So I probably have another video out of this on how I'm going to fix that later, because what we're doing in prod is quite wasteful. But anyway, profiled this. 3.12 looked faster or roughly equivalent in all the cases that I was looking at. But mysteriously, the workers that we were running would suddenly die after a while. And, we would still get this listen queue lockup, and a socket full problem, and could not figure out what was going on, despite profiling it. And we actually couldn't get a profile while this was happening. So the one thing that I really wanted was to find a profile while it's locked up. The theory being that the workers are doing something, and so we can see what they're stuck on. But unfortunately, as soon as it locked up, health checks no longer get processed because the listen queue is full. uWSGI is dropping the requests on the floor, and so Kubernetes would nuke the pod. We couldn't figure out the profiling there. But I did notice something really, really interesting. And that is when I looked at the logs in isolation, I saw a pattern that looked like this. I gotta make it bigger so you can see the whole thing. And for context, Sentry runs 16 workers in this particular web type that I was looking at. And so you can see these kind of numbered 1 to 16. Now you'll also notice that this is another bad log message that you probably don't ever want to see in production, and is telling me that something else is going very wrong. In this case, uWSGI is brutally killing workers. A bunch of stuff is left out here because the workers operated normally until they got to this state and then fell at a load balancer. But if you ever see killed in your logs, this means that workers are not recycling gracefully. uWSGI is having to come by and nuke them from orbit with a kill-9. And that's another problem. We'll get to that in a second. But I saw this log and I formed a new hypothesis about what is happening here. You'll notice, and I'm not going to count this for you, but I think there's about 14-ish here, and we're running 16 workers in production. So after killing about 14 of these workers, we start filling up this listen queue. And I checked, and like these kills don't happen all at the same time, so it's not something where like they all die at once, then we fill up the queue and then never recover. That's not what's happening. These were staggered pretty well. uWSGI has an option to help you stagger these. But after most of the workers died, the listen queue would fill up and then the pods would die. And so my new hypothesis here that I sought out to either prove or disprove was that workers were being killed and then never coming back. Turns out I was right, but I'm going to show you the process that I went through to both debug these kill messages, because they shouldn't be happening, and to find the case where the workers go away and never come back. Okay, so in order to do that, we're actually going to show you how to get this killed message first, since I think that one is interesting. I got to show you some other stuff before I shrink the window down. I have made a shell script to run uWSGI. uWSGI has a hilarious number of options, and it just keeps going. And I'm not even, that's fast scrolling. Like if I drag the scroll bar, it just keeps going. uWSGI has so many options. It is hilariously complex. But anyway, ignoring all that, these are some of the options that we run for uWSGI at Sentry. These aren't exactly the same, but this is, I stole this from the development instance of uWSGI. And they're all configured as environment variables, and I will show you, we're actually going to do this first. We're going to add uWSGI threads here. So that's the first thing I want to show you. uWSGI threads equals 2. Now in this mode, we've configured uWSGI to have 2 processes, 2 workies, 2 processes, and 2 threads per each process. So a total of 4 things that can pick up requests and process them. I've also set up a trivial uWSGI.py. This is basically the simplest Python server that you can make. In this case, it's always going to respond with a 200 text plain and a body of just 1 exclamation mark. This is going to be important later when we actually run a bunch of requests and look at the output so that we can see them happening. But very simple app. We are going to make a Python 3.11 virtual env, /p Python 3.11, and I am going to activate that and install pyuwsgi. Oh, I forgot to, oh no, I did talk about, yeah, this is wheelable. That's why it's great. The other difference between pyuwsgi and WSGI that I didn't mention is pyuwsgi actually ships as a module. So if we look in VM lib site packages, there is this pyuwsgi.so, essentially a C module. And if you run Python, you can import pyuwsgi. And you can't do that with uWSGI. uWSGI is a bin binary instead of a module. There's some quirks to doing it this way, but that's how it works. Anyway, okay, so now we've installed pyuwsgi. I am going to run that shell script that I made before, and we have started up our app. Our app's going to show up in the top up here. We got our 2 workers, 2 cores. Great. And I'm going to run a curl command in the bottom that I prepared before. This is basically, so this shell pipeline here calls yes. Yes just prints out yes repeatedly, line per line. I'm grabbing 100 lines from that. I'm using xargs with 4 processes and replace mode, but I don't have any curly braces here, so it's not actually sticking the word yes anywhere into this command. This is just a cheeky way to do something 100 times. And so we're going to call our endpoint. The uWSGI app didn't actually read the URL, but health check is what I was using before. And you'll notice here that, actually, I'm surprised it didn't pause longer. Oh, probably because it just started up for the first time. If I run this a bunch, you'll notice that there's a pause. Maybe not at the bottom here. There's a pause, and that's when the workers recycle here. And sometimes there's a longer pause. Oh, wait. Did I accidentally upgrade this in the... Oh, right. It's in this unkillable state. Okay. Sorry. Live demos, they always go great. Let me just make sure I'm on the right version. Oh, I know why it's taking a lot longer to reproduce. It's taking longer to reproduce because I have 4 workers, and when I demoed this before, this number was large enough. Anyway, let's start that again. Great, we're up, and let's put this at 1,000. And this is going to run for a while, but eventually it's going to get stuck. Right? Right? You're going to get stuck at some point? What do you mean? Okay, well, you'll have to take my word for it. Wait, why isn't this working? And that time it died gracefully. Did I set the threads thing correctly? Did I remember to save? I did. uWSGI threads. Let's make sure I didn't typo. Very strange. Anyway, when I ran this locally against Python 3.11, it is 3.11. This was eventually locking up. Oh, here we go. Okay, I did it there. It was locking up, and uWSGI had to brutally kill the worker in order to continue processing things. And then while killing those workers, it's never, you can see it's hanging here. Like this is the most trivial uWSGI app ever. It should die immediately. And so that was leading to those worker X killed successfully lines. But that wasn't my problem. This was already happening in Python 3.11, and so it wasn't the problem that I was searching for. But it is a different problem. It means that we're being a little bit wasteful of things. All right, build-9%1. It does mean that we're being wasteful in production because when our workers reload, gracefully reload, they don't gracefully reload. They hang out for 30 seconds until they get killed. Although in this case, it was only 2 seconds, probably because I used a different option or something. But let me show you the problem with 3.12. Let's deactivate, make a new virtualenv with Python 3.12 and pip install pyuwsgi and show what happens with this. I'm going to remove the thread since that's what was causing that other hang. But if we run this again and we run this a bunch, I guess we need quite a lot for it to reload here. I'm surprised how much. There we go. We got to our request limit eventually. Why did it take so long to get there? Anyway, you'll notice here that the process was done and it got nuked and then it got respawned. And normally when a process respawns, it will load up the app again and start processing work. But in Python 3.12, with that version of pyuwsgi, it no longer did. These things died and never came back, which explains that log that we saw before, where most of the workers in production died. They were still receiving production traffic, so they filled up their listen socket, and then eventually Kubernetes killed it. And actually, if I increase the number of processes here, we should be able to actually see that same queue fill up line here. Yeah, so you can see listen queue is full, uWSGI is in full panic mode. Like, this is bad news bears. Now, all of that said, so I told you about uWSGI, told you about the struggle that I went through to upgrading Python 3.12. How do we get to the point where I am now maintaining this thing? So I put together a bug report where I outlined all of these things that I've just showed you now in a succinct format that anyone can run. And I noticed that the version that was available in pyuwsgi is pretty old. There are newer versions available. And I showed the same reproduction that I did before. The shell script, the WSGI app, and the curl command. And the maintainer went to build the newer versions of uWSGI and unfortunately couldn't get past some failing builds and offered to have me maintain it. And while recently, and actually this is probably maybe too much information, but like recently I have been trying to step back from open source a little bit more. I'm sort of realizing that it's not as fulfilling and enjoyable as it previously was for me. Now, granted, there are projects that I love working on, but in general, I'm not looking for more maintainership, and I've been stepping back from a lot of the roles that I have. But anyway, this I felt was small enough that I can get it working and not have to think about it again, and also unlocked some stuff that I needed for work. So a little bit of a lose-win-win, and I'm hoping the lose is not too much. But anyway, I said, yeah, you can sign me up to maintain this, and if you tuned into my stream, it's going to be probably weeks ago when this video comes out, we got this build working. So yeah, that'll fix it. And also, this problem doesn't happen in newer versions of uWSGI, and so I have fixed the problem. The other cool thing is, while making this work and rebuilding 2.0.26, I also got macOS ARM working. So I fixed one of the other problems at the same time. We'll get into this working. Oh, this is a long video. Sorry about that. Anyway, I hope you found something interesting about this, about a process that I went through in debugging and production. I managed to somehow get it reproducing locally, found two pretty bad bugs, one in 3.12 and one that's currently happening and unfortunate, and then ultimately fixed the problem, and now I have another maintainership. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.